This is a piece of metal that has been cut so perfectly that you can't even see that there are actually three separate pieces here. This part was made using a process called wire EDM. With this technique, you can machine parts to within 5/1000ths of a millimeter. This cube is called the Metmo cube. At the bottom, there's a small connection so that the pressure on both sides is the same. So if I push one piece down, it pops up the other. When I flip the cube over, the two moving pieces want to fall out, but the atmosphere keeps them in because in order to fall out, it has to open up a space below it. But now let's drop the pressure in this big vacuum chamber. Okay, so now we're gonna close this up and see what happens when it's under vacuum. We're going to get to less than 0.05 atmospheres. So the air pressure is now 20 times less than normal atmospheric pressure. Okay, let's turn it upside down. What? Wait, they fall out fast initially, but then they slow down. And when I turn it back upright, they fall in fast, but then for the last little bit, they slide in at about the same rate as they slid in before. Let's try this again. So when we turn it upside down, the pieces fall out easier at first because there's less pressure outside to push against them. But in doing so, this creates a vacuum in the gap under the moving piece that's now a greater vacuum than the outside vacuum. So the very thin air from the outside moves into the gap. Then when I flip it upright, there's a little bit higher pressure on the inside than the outside, so that little bit of air has to escape through the tiny gaps before it can fall all the way down. But what's weird about this is that even though the pressure on the inside is slightly higher than the outside, it's still a very low pressure, less than 0.05 atmospheres. But that very thin air has just as hard of a time escaping through the gaps as when it was at a pressure of 1 atmosphere. This happens because the viscosity of air is about the same whether it's at atmospheric pressure or a lower vacuum, and that's what's making it hard for the air to slide in.